Hello everyone, welcome back to BC Calculus. We're still in lesson 34 and we're talking about partial decomposition. In this video, I'm going to show you guys how to solve problems for partial decomposition where we have nonlinear functions. Before I get to that, I want to say something about partial decomposition when it's nonlinear. For example, if we look at this expression and we were going to integrate this, we would factor them out and we would have an x squared and we'd have an x plus 1 and an x minus 1. This is actually not the correct way of setting this up. So if you have multiple factors, then you actually have to have stuff that lead up to it in order for partial decomposition to work. So what I mean by that is this. We would have to have a to be over x, and then b would have to be over x squared. So if we have x squared, we need an x. And then the rest would be c would be x plus 1, and then d would be x minus 1. Another example of that we would want to do, if I gave you something like this. And we're going to see this in the example we're going to do for this video. But if I ask you guys to factor the bottom and we get x times x minus 3 quantity squared, then when we break this apart, we're going to have a over x. Then we would have to have x minus 3 solo. We would actually have to have the first term of that linear function of this as our, and then we would have to do x plus minus 3 squared. So that's one thing that I want to stress with you guys about that, is that if you have something squared or even something cubed, if I had x cubed as one of my factors, then you would have to have an x, you would have to have an x squared, and then you would have an x cubed. So you have to be able to go up to what it is, starting with the degree of 1 up to the degree that what we're doing. So I wanted to say that really quickly as we start our first and only example in this video. So again, I would check u sub. U sub's not going to work here, so we're going to go ahead and start factoring this. And so we're going to get x in the denominator, x squared plus 2x plus 1. And then when we factor this, we're going to get an x plus 1, x plus 1. So we actually have x times x plus 1 squared. So just like I said at the very bottom, we have actually a root that is squared, well, a factor that's squared. So when we do this, we're going to do a, and we're going to have x, which is our first term, and then b is going to be the singleton. It's just going to be x plus 1. We need that. And then c is going to be over x plus 1 squared. So I'm going to go ahead and resolve this right now. And so this is what we need to do. First off, we cannot use the Heaviside method from video number 2 because we have a nonlinear function here. So we actually have to go back to the whole first video that we do with our problems. So we're going to go ahead and write x minus 5 on our paper. Then we're going to do a times x plus 1 quantity squared plus b times x plus 1, and then c times x. Now, if you're sitting there thinking, what did he just do with that? Well, what I did was, remember, I multiplied every single term. So this term, this one, and this one by x times x plus 1 squared. So this is what this factor is. So that's why it's just x minus 1 on the left-hand side. The x's are going to cancel, and so that's why I'm left with the x plus 1 squared. If I'm multiplying b times all this, well, here's the x, and then I'm going to cancel one of these x plus 1s with the square. And then c, I'm going to cancel the x plus 1 squared with this, and I'm left with an x. So if you were sitting there wondering what I did with this, it's because I talked about that more in the first video. Okay, so first thing we're going to do is we're going to set x equal to -1. If we set x equal to -1, then the a term is going to go away and the b term is going to go away. So the only thing that's going to be left is c, because this is also going to be 0. So setting x equal to -1 will eliminate the a term and the b term, and that's awesome for us. That's awesome for us because now we're going to get c. So we know that c times -1 is going to be equal to, we're going to plug in -1 over here, -1 minus 5. So negative c is going to be equal to -6. So c is going to be equal to c. So let me go ahead and erase c here and make this equal to 6. Now let's go ahead and start with a. So if I make a, well, let's set now x equal to 0. If I set x equal to 0, then my b term is going to go away and my c term is going to go away. And so all I'm left with here is that a, I plug in 0, I get 0 plus 1 squared, and that's going to be equal to 0 minus 5. So a, and this is going to end up being 1, right? 0 plus 1 quantity squared is 1, is equal to -5. So I know that a must be equal to -5. So a is going to be equal to -5. Now, we have to look at what to do for b. Now, the way I'm going to do this problem is probably a little unconventional to what some other people do. I like to do it this way just to show you guys just kind of a weird thing about these problems. But I'm going to do x minus 5, and then I'm going to substitute in for a as negative 5. And I'm going to go ahead and FOIL this out. So I'm going to get x squared plus 2x plus 1. And then I'm going to leave b alone because I don't know what that is yet. We're going to go ahead and FOIL this. We're going to distribute the x, so we can get x squared plus x. And then we're going to go ahead and replace the c with 6. And so we have this. I'm going to do one more thing. I'm going to simplify this a little bit more, just to this piece right here, where I distribute the negative 5 here, I distribute the b here, like so. Now what I want you guys to see here is this. The left-hand side has to equal the right-hand side. They have to be equal to each other. So this term does not have a x squared. These do. So I know that if I were to simplify the right-hand side, I would say negative 5x squared plus bx squared has to be equal to 0. They have to cancel each other out, because again, there's no x squared over here. So I know right now that b has to be equal to 5. It has to be equal to 5. If that doesn't make sense, or you're still a little bit on the fence with this, well then this 1x on the left-hand side has to be equal to the simplification of what you see on the right-hand side. So 1x must be equal to negative 10x plus bx plus 6x. So I have that 1x must be equal to negative 4x plus bx. So again, if I move the 4x over, I get 5x equals bx. So b is equal to 5. So two ways of looking at that. The other thing that we could actually see here is that there's only one constant on the left-hand side, which is negative 5, and there's only one constant on the right-hand side, that's negative 5. So these have to be equal to each other. So that's an unconventional way of doing finding the b, but I think it's just a nice way of doing it. So I know that b has to be equal to 5. So let's make b equal to 5. All right, so the next thing we need to do is now actually integrate. So that was all the algebra manipulation for the problem. So I'm going to go ahead and pull out the constants because that's just a thing that I can do here. So I'm going to go ahead and pull the constants out. And we're going to integrate these separately like we normally would. Oh, that was a weird integration sign right there, right? Okay, so the first two is pretty straightforward. Use u sub, you're going to get the natural log, right? You're going to get the du is equal to 1 dx, du is equal to 1 dx. So this is going to be the negative 5, and it's going to be the natural log of u, right? This integration of 1 over x is just the natural log of u. So it's going to be the natural log of x. And then this right here is going to be plus 5. It's going to be the natural log of u. Well, the natural log of u is going to be the natural log of x plus 1. Now, this one, ladies and gentlemen, is not the natural log of x plus 1 quantity squared. So this one we actually have to think about more. We need to make u equal to x plus 1, which we did in the rest of them. Du is going to be equal to 1 dx. So when and I'm actually showing the work for this one. So this one, we're going to be left with the integration of 1 over u squared du. This is not 1 over u like the other ones would be, right? Because remember, the integration of 1 over u du is the natural log of u. So I just did these two based on this function right there, because this ends up being 1 over u, 1 over u. But for this one, you have to be careful. It's not the natural log. It's u to the negative 2 du. So when we integrate u to the negative 2, it's actually u to the negative 1 over negative 1. So it's going to be negative 1 over u. So that's what this one's going to integrate to. So I'm going to change the color on this one to make sure. So we still have our 6, and it's going to be, well, actually, let's make it negative 6, because we have a negative here that we have to take into account. So negative 6 times 1 over our u, which is x plus 1 plus c. Or negative 6 over x plus 1 is also a legit answer for that problem. So there is your example on how to do a nonlinear partial decomposition, and I will see you guys in the next lesson. Take care.